everyone, how are you? So today I'm discussing with a very interesting topic of statistical mechanics, that is random walk. Let's start our video. So if you like my explanation, you can like and subscribe my channel for more videos. So in statistical mechanics, we are going to deal about a very important topic, that is random walk. This is MSc topic, and this question is very important for point of exam. So what in beginning we have to assume that, for example, we have to assume that there is a drunk man who is initially at a x equals to 0 and can move along a x-axis. So let us consider a drunk man who is initially at x equals to 0 point and can move along a x direction. He can move along the x direction. Okay, so he is at this point x equal to 0 and he is moving along the in this direction. Okay, so moving further, he makes a n steps. So this drunk man makes a n steps. Okay, and if a drunk man uh, keeps his steps towards right, it is taken as p steps. Okay, when this drunk man takes his steps towards the left, it is taken it as a q. I hope you clear. So first we are taking a example, that is a drunk man take a random steps or a random walk. He starts from the initial point at x equals to 0 towards x-axis, and he walking or he taking a n steps, let us assume like that. And when he take steps towards the right, it is taken in a p steps, and when he taking steps towards minus x direction or a left side, is taken as a q. I hope you clear this. I hope you understood this one. And moving further, if we add p plus q, this answer is 1. If we add the steps from the right side and steps from the left side together, it gives as a p plus q is equals to 1. So stepping towards the right and left independent of previous steps. So when a person steps towards right or a left, these are independent of each other, independent of previous step. Means whatever he kept previously, that is not depend upon the steps which he kept afterwards or ahead. Okay, so those are independent. So the moment is not biased. So let's take the equation like, we will draw once again that number line. Okay, for understanding purpose, we have a drunk man who starts his steps from x equals to 0. In the right side, he walks in a p steps, and in the left side he walks in a q steps. And then, so let us assume this direction is regarding +1 direction, and this is, if we take a backward, that is a -1. Okay, so this is our number line. I hope you clear this. Then so we have a total number of steps, because initially we took it as a n. Total number of steps is n. Okay, I hope you clear this point. Moving further, so towards right we have how many steps? Towards right we have a n1 step. Towards left we have a n2 steps. Okay, together we can write it as we have a length as a L. So we have a length of those steps as a L. Okay, so we can write equation like x equals to initial means this right side steps minus left side steps along with this length. So can I take L as a common? So remaining is n1 minus n2. And moving further, can I take a n1 minus n2 is equal to n? So just a substitute here. So n into L. I hope you clear this one. Okay. So I can take this as a n, or else I'm taking it as a, because let's take a different alphabet, because already I have took a n1 and n2 for a right and left. Let's take it as a m. Okay, so m into L. No problem with this. We are clear with this. So at the end of nth step, so we have to go for a at the end of the nth steps of a position of a person. So nth steps of a position of a person. So it can be written as m is equal to, I have written over here, n1 minus n2. This is given as a equation number 1. I hope you clear with this. Okay. So from this, can I write n1 plus n2 is equals to total number of steps. So n1 plus n2 is equals to total number of steps. If I need a n1, can I write n1 is equals to n minus n2? N minus n2 minus of n2. So n minus n2 become n minus 2n2. Okay. So this is my total or a n steps of a position of a person. I hope you clear up to here. If you want any screenshot of this solution, you can take. Moving further, take a condition that is if a n is even and m is also even, because in the last equation what we got, in the last equation we got m is equals to n minus 2 n2. Okay, or else if you substitute for a n2, we may get it as a m is equals to 2 n1 minus n. So this is the thing. Okay, we can get both the equations. How we substitute it, we get like that. So from this I'm writing n is even and m is even. So if we take a n is odd, then and m is odd, m is also odd, then what are the conditions are, or what are the things to be changed? So the thing is px into px into px so on up to p. These are the steps from the right side, and in the left side I can write it as a qx into qx so on to q. So I can write these two series in one equation format, that is p to the power of n1, because I have said no, in a right side we have a n1 steps and in the left side we have a n2 steps. Let's name it as equation number 3. I hope you clear with this. So this what you are writing now, this just you explain it in a 2 to 3 lines with your own words. What you are going to write, you just write n1 is the number of steps towards the right and p is also number of steps towards the right itself, and q and n2 are the steps towards the left. That's it. Okay, so moving further, if total n steps with the n1 to the right and n2 to the left, if we take a n steps towards n1 and n2, n1 at the right side and n2 to the left side, then in probability we can write it as n factorial divided by n1 factorial into n2 factorial. This is very important part. Okay, so moving further, if we go on solving this, we get Let's take a probability function for a n1 for a right side. So probability function can be written as n factorial divided by n1 factorial into n2 factorial p to the power n1 into q to the power n2. Okay, name it as equation number 5. Okay, so in earlier we know that n1 plus n2 is equals to capital N. If I substitute for a n2, can I write it as a n2 equals to n minus n1? So just to substitute over here. So n factorial divided by n1 factorial into n2 factorial p to the power of n1 q to the power of n minus n1. So x equals to m into L, which is we derived earlier here. So just substitute this value over here. Okay. So we have a x equals to m into L. So can I write n1 is equals to n plus m divided by 2, or else n2 is equals to n minus m divided by 2. Okay. So if I substitute these two over here, what is the answer? Wn into n1 is equals to n factorial divided by n1 factorial into n2 factor p to the power of n plus m by 2 and q to the power of n minus n minus n plus m by 2 if we substitute here. Otherwise you can substitute also in the fifth equation, or else it will become n factorial upon n1 factorial into n2 factorial to the power of n plus m by 2 q to the power of n minus m by 2. Okay, so this is the solution. So after that, so you can write this as a solution, or else for a final equation, for the probability of a person travel in a x equals to ml, person travels in a x equals to mn, the last equation can be written as w n of n1 to n1, so which is equals to n factorial divided by n1 factorial into n2 factorial, so pn. So this n1 and n minus n1, these all I'm removing and just I'm keeping it as a in general format, that is n. So q to the power of n minus n. I hope you cleared with this equation. Thanks for watching and keep subscribing.